Okay, we're now recording. Let's start with 9-2 rules of probability. So, probability at its core is just the number of times you want something to happen divided by the total number of times it could happen, or the number of outcomes. So, really simple example would be, say you have like 100 marbles in a jar, and 20 of them are red. Let's probably get a red marble. 20 out of 100. There you go. Pretty simple stuff. So that's at its core. There are some fancy formulas here, which I don't know if I'm going to totally get into these so much, but they probably have two events occurring at the same time. Let's say, for example, what's a probability of flipping a coin and getting heads? And the probability if I roll a die of getting, like, say, a 6. So say I want tails and a 6. Well, probably getting tails is 1/2. Probably getting a 6 if I roll a single-sided die is 1/6. So the probability of both those events occurring simultaneously, like I flip a coin and I roll a die, it's 1/12, right? So they're independent because the coin doesn't impact the die and the die doesn't impact the coin. So they don't have any impact on each other, so they're independent. So you can see stuff like that, perhaps. And even if it does have an impact on it, if it's dependent, like we'll look at an example coming up soon, you still calculate the second probability, making an adjustment, but you multiply the first probability, the second probability, like we did earlier on. A lot of that kind of comes back to the multiplication counting principle, where you're kind of multiplying all the number of ways of something happening. There's another one, the probability of A or B happening was probably this or this. In this case, you just add them. So give you a good example would be, like what's the probability, oh gosh, I'm trying to think of a good example here. Like what's the probability that it will rain tomorrow or it will rain the day after tomorrow? So I'm not looking for and, it's just one or the other. So let's say it's 30% chance today, 40% chance tomorrow. So probably a rain on at least one of those 2 days would be 70%. You just add them up. That's kind of an example of that one. So here we have a bag, has 6 red balls, 4 blue balls. 2 are selected at one at a time. If I'm probably selecting red, then a blue, the first ball is replaced during the second draw. So again, getting a red ball first is 6 out of 10. Getting a blue ball after that will be 4 out of 10. Because remember, you are replacing, so you still have 10 to choose from. And it's 24 out of 100. Or they reduce to 6 or 25. Now, if I'm probably getting a red and then a blue, the first ball is not replaced. So getting red is 6/10. And you still have 4 blue balls, but now you're only picking 9 out of 9 balls, right? Because you didn't replace. So you have to make that adjustment. If I'm put that both balls are the same color and the first ball is not replaced for the second one. So let's say we get 2 reds in a row. You're not replacing. You have 30 out of 90, so you have 1/3 chance. Or let's say you get 2 blues in a row. 4/10 times 3/9, which is 12 out of 90. But you're looking at one or the other, like what's probably of either one of those things happening. So then you could add those 2 probabilities together. You get 7 out of 15. So some good problems we could try here. Again, I'll probably do the first. I'll just do the first 2 because I'll give you guys more of a chance to do some stuff in groups. So let's take a look at this one here. So bag contains 15 balls, numbers 1 through 15. Was probably select a number that's odd or a multiple of 5. Okay. So in this case, and actually there was one little thing, yeah, I think it was kind of left out, but that's okay. So getting an odd number or a multiple of 5. So which of those would be odd? Obviously 1, 3, 5, 7, 9, 11, 13, 15, right? What are multiples of 5? Obviously 5, 10, and 15. Now I notice there's some overlap, right? Like the 5 kind of overlaps and the 15 overlaps. So really I'm just gonna look at these here and then the 10 here. And so what are my desired outcomes? 1, 3, 5, 7, 9, 11, 13, 15, and 10. Those are my desired outcomes. How many desired outcomes do I have here? It looks like I have 9 desired outcomes, 15 possibilities. 9 out of 15 is my answer. Now, if you want to use that formula of the probability of one event plus the probability of another event when you see the word or, you could do that, but then you have to subtract by the overlap of the probability of getting both at the same time. So probably of the first event, getting an odd, was 8 out of 15. The probability of getting a multiple of 5 was 3 out of 15. And then the overlap, there was 2 that satisfied both. That was 2 out of 15. And then, of course, you just work it out and get 9 out of 15 still. And these are not necessarily independent, so we can't really, like, probably getting both A and B, we can't just multiply A and B together necessarily. Actually, could you? Let me double check. I don't think we could. No, we can't. Yeah. So, but you know, we just could just count it. A ball selected at random, then replaced with in the bag. The second selection is then made. What's the probability that the first number is a prime number and the second number is a multiple of 3? Okay. So getting a prime number. Now this case is independent because you do one draw and then you do a totally separate draw. It's not like there's any memory there. I'll show you. I'll share one really good example with you guys, and then let you guys get to work. So of getting a prime number. So which of these numbers are a prime number? One's not a prime number. A prime number has to have exactly 2 factors. Like 2 is a prime number. 3, 5, 7, 11, and 13. Those are the only prime numbers I got. So that's 6 out of 15. Then your second draw, you want a multiple of 3. Well, there are 5 numbers of multiples of 3 from 1 through 15. So 5 out of 15. And that's 2/5 times 1/3 is 2/15. I think I did that right. Yeah. So that'll be your answer for that one. Now, the one thing I always find kind of amusing when you guys get old enough and when the pandemic is over, maybe it's over hopefully by the time you're 21. If you ever go to a casino, you'll see a roulette table that looks like this. And usually you'll get a bunch of young people who, for one reason or another, are not really thinking straight. So I won't go into reasons why they wouldn't be thinking straight if they're 21 at a casino, but you can use your imagination. And so usually the most popular bets are like betting on red or betting on black. And you can see there's a bunch of like numbers are red, a bunch of numbers are black. There are actually 2 green numbers, a 0. And usually there's a double 0 also. I don't see this in this wheel. So in this case, there are actually 37 spots where the ball can land. Oh, let me get a different color here. And let's say you bet on red, okay, and there's 18 red numbers. So you have 18 out of 37 chance if you put your money right there, you bet on that. And then what happens sometimes, usually there'll be a screen. Yeah, it kind of looks like this a little bit. usually it'll show like what numbers have shown up recently. I guess if you want to run a casino in your house, you could buy this if you want. So anyway, and so sometimes like someone will say, oh my God, a red number showed up 4 times in a row. So someone's going to feel so inclined then to bet on black, right? Because hey, you know, if red has shown up, like let me just go back one more time. Yeah. So you know, going back to the, this roulette table, you know, if red has shown up like, you know, 4 times in a row, or sometimes like I've seen red show up, you know, 10 times in a row. So the ball landed on a red number 10 times in a row. So naturally it should be black, right? But here's the thing, the wheel doesn't have a memory, it doesn't know what happened in the previous roll. So they're all independent. So it actually is a foolish bet. You'll see someone will probably put like $1,000 or $2,000, something really crazy, figuring, oh, it has to land on black. And it's gambler's fallacy. It's actually one of the dumbest things you could do. So don't do that, please. If you want strategy, there's actually different strategies you could play, or blackjack's kind of a fun one. We can always talk about that later, but this is always my favorite unit because it does involve a lot of the games of chance and number theory and stuff like that. So, or sorry, game theory, I meant to say. Anyway, but that would be, if you want to see how many times you get, you know, red in a row, yeah, you would do 18 out of 37 times 18 out of 37 times 18 out of 37. It is very unlikely that the roulette wheel will get 18 out, you know, red 10 times in a row if you actually were to multiply that out. But it is independent though, so you can't expect to be black on the next. It's on the next one. It's still going to be the same probability. Anyway, so how do you guys do 3, 4, 5, 6? And it looks like we got 7 people here now, so that's good. Actually, let me just make sure I got everyone's name here. Okay, so I'll put you guys, we'll do 3 groups here.